Our topic today is an old topic, reactions. Reactions, how to calculate reactions for any structure. We have three different types of supports. I covered this last meeting. We have fixed support, has three reactions: vertical reaction, horizontal reaction, and concentrated moment. We have hinge. We have two reactions, forces, two forces, one vertical and one horizontal. This support can be called hinge support or pin support. The third one called roller. Do you remember how many reactions for roller? One reaction, vertical or horizontal? No, this only one reaction perpendicular to the base of the roller. Perpendicular. Just to remind you, for any structure who is stable and determined, last meeting we learned what is the meaning of stable and determined. Any structure who is or which is stable and determined can be solved using three equilibrium equations. Summation forces in x direction equals 0, summation forces in y direction equals 0, summation moment at any point equals 0. For any structure which is stable, we can apply three equilibrium equations. Summation all forces in x equals 0, all forces in y equals 0, summation moment at any point equals 0. Just to remind you for something, if you have inclined force like this one, and you have this angle given for this force, we can break this force to two components, one horizontal component and one vertical component. Which one is cosine and which one is sine? The component adjacent to the given angle, this component, the horizontal one, is adjacent to the given angle. So this component will be f cosine theta. The far away component from the angle will be sine. So we have f sine theta. Sometimes theta is not given. Sometimes we have right angle triangle is given. Just to remind you, if you have right angle triangle like this, if this one is 3, this one is 4, the third member will be 5. This angle, theta, I can say sine theta equal the opposite 3/5. Cosine theta equal the adjacent dimension 4 divide 5. This angle equal to this one. So this component will be f cosine and this component will be f sine. Guys, to make it clear, it's not accepted in this course to be confused about components of inclined force. If you have inclined force like this one, and we need to convert it to two components, if the given angle is here, so the component adjacent to the given angle will be cosine. The component far away from the given angle will be sine. Probably this angle is given, probably you can get a right angle triangle, 3, 4, 5. if this is your angle, I can figure out the sine theta opposite 3/5, cosine theta adjacent 4/5. Any question so far? Any question so far? If you have any question, let me know. I believe I'm reminding you what you learned during engineering mechanics. Okay, looks good. One more thing. Sometimes we have something called distributed load. Distributed load in this course will be only two shapes. Uniform, like this rectangle, or triangle like this one. Right angle triangle. W, this length is L, this length is L. We have kind of load called distributed load. This load can be uniform or non-uniform. We need to make equivalent for this distributed load. The equivalent load or the equivalent force for this rectangle distributed load will be a force called F. This F at a value equal this area. This is a rectangle. The height of this rectangle is W. The length of this rectangle is L. So the area of this rectangle W times L. If you would like to convert this distributed load to equivalent load, you have to multiply the distributed load value times the total length of this distributed load. You can get the equivalent value. Where is this position? At the mid-span, this length must equal to this length, L divided 2, L divided 2. For example, we have uniform distributed load equal 5 kb per foot. The total distance for this distributed load equal 10 feet. What is the equivalent value for this force? We have equivalent here. This equivalent equal to 5 times 10 equal 50 kb. So this distributed load is equivalent to, this force, which is 50 kb, is equivalent to this distributed load. Be careful. This 5 is not the value for the equivalent load. This 5 is the value for this distributed load. To convert it to equivalent, you have to multiply this 5 by this total length 10. Where is the position of this equivalent force? At mid-span. So this length will be 5 feet. And this length will be 5 feet. If you have right angle triangle, this W is the value of the distributed load. It's non-uniform, but still distributed. We have equivalent. How much? The area. I told you the equivalent force equal the area for the distributed load. What is the area of this right angle triangle? Area of any triangle equal 1/2 times L times W. 1/2 times base times height. Where is the position of this distributed load? At the centroid of this right angle triangle. So from this side will be 1/3 L. From the other side will be 2/3 L. For example, if you have right angle triangle like this with length equal 6 feet and this value equal 4 kib per foot, we need to figure out the equivalent value for this distributed load. So this distributed load can be converted to equivalent value here, equivalent force. How much? How much for this force? The area of this right angle triangle, 1/2 times 6 feet times 4 feet equal 12 kib. So this force equal 12 kib. Where is the location of this force? From the side of the height of the right angle triangle, 1/3. 1/3 of what? Of L. The other one will be 2/3 L. The L here equals 6, so 1/3 L equal 2 feet. 2/3 L equal 4 feet. So if you have uniform distributed load like this, or right angle triangle distributed load, I can convert any of them to equivalent force. To equivalent force. What will happen if you have this shape of distributed load? This value is 4, this value is 10 kib per foot, this one is 4 kib per foot. Okay, this shape looks like we have this rectangle of value 4 plus this triangle with value here equal what? What is the value of this right angle triangle? Any answer? So I divided this trapezoid to rectangle of distributed load with 4 plus right angle triangle. Can you tell me what is the value of this right angle triangle? Any answer? Thank you, Benjamin. Yes, 6. 6. Then I can get the equivalent for this one at the midspan, equivalent for this one at 1/3 and 2/3, and that's it. So if you have uniform and triangular line load, I can get the equivalent force, and make sure you can understand where is the force. Let's start our first example, example number 3 for this problem. Determine the reactions for the shown beam where support A is hinge, support B is roller. First step. How many reactions do you have at A? A is hinge. If you have hinge, we have 2 reactions. So at A, we have 2 reactions, one vertical, one horizontal. The vertical one can be called Y at A. The horizontal one can be called X at A. B can be considered as a roller. If you have roller, we have one reaction perpendicular to the base. So at B, we have one reaction can be called YB. Do you have uniform distributed load? Yes, we have. For this rectangle, we have equivalent here. How much? How much for this equivalent? 2 times 12 equal 24. Kip. Where this distance will be 6 feet. This distance will be 6 feet. That makes sense. That makes sense. Because we have uniform distributed load. What else? We have right angle triangle. This one. So we have equivalent. How much? How much? 1/2 times 2 times 12 equal 12 kib. Where this distance guys, looks like I have a technical issue here. Just a second. Hey guys, can you hear me right now? I'm sorry for this error. Okay. So the equivalent force for this right angle triangle will be 1/2 times 12 times 2. It will be 12 kip. What is the distance here? What is the distance here? One will be 1/3. This side will be 4 feet. The other one will be 2/3, 8 feet. 1/3 for the side of this value, of the highest value of the right angle triangle. Anyway, so finally, I converted this beam to something looks like this. We have here reaction YB. We have here two reaction YA and XA. For this part, we have equivalent force 24 kip, and this part we have 12 kip. This distance from this side is 4, from this side is 8. This distance from this side is 6. This side will be 6. This is point A, point B. The last step, we need to apply a Coulomb equation. We have 3 summation forces in x equals 0. What are the forces in x direction? Please list all of them. Please list all of them. We have XA. What else? Do you have anything in x direction except XA? Nothing else. So XA equals 0. Summation forces in y equals 0. What do you have in y direction? We have YA positive, negative 24, negative 12 plus YB equals 0. Please list all of them in y direction. We have YA, we have 24, we have 12, we have YB. Upward is positive, downward is negative. You can simplify this equation, YA plus YB equal 36. We have 2 unknowns. The third one, summation moment at any point equals 0. Summation moment at any point equals 0. Any question so far? If you have any question so far, let me know. Guys, probably it was accepted to make error or to make mistakes for reaction in engineering mechanics. But in this course, it's not accepted. Reactions are the basics for any problem in this course. It's not accepted at all for any student to make error or mistakes for calculating reactions. So be careful. Before continue the reaction calculations, I would like to highlight something for you. Moment equal force time distance. But this force and this distance must be perpendicular. I'm sorry, what you mean by force and the distance must be perpendicular? I mean, if you have a point like point A and you have a force like F, if you would like to get moment of this force around this point A, we need to multiply this force by distance. Where is the distance? Your distance will be like this. Here is the distance. Can you watch the direction of the force and the direction of the distance? The force is vertical, the distance is horizontal, both of them are perpendicular. One more time. If you have a force like this force, and you have a point like this point A, so moment around point A for this force will be F as a force time distance. Where is your distance? Your distance will be like this. Here is the distance. Can you watch? What is the relationship between the direction of the force and the direction of the distance? Both of them are perpendicular. Both of them are perpendicular. Fatal mistake. It's wrong. Not accepted. If you have point A and if you have a force like this, and you say MA equal force time distance, and you are saying distance is this one, that's wrong. Why? Because the direction of the force is horizontal. The direction of the distance is horizontal, both of them in the same direction, you are doing a mistake. But if your force like this and your point is here, your distance must be something like this. The distance between the force and the point must be perpendicular. Must be perpendicular. Must be perpendicular. If you don't have distance, that's fine. But your distance and your force in the same direction, that's wrong. Is it clear? This point is clear for you? Okay. So I decided to take moment at point A. XA will be times 0. What is the distance between XA and point A? We don't have distance. Both of them at the same location. YA times 0. We don't have distance for YA between YA and point A. Plus, if you take moment at A, I decided this clockwise direction will be positive. Okay, so what is the next? The next force will be 24 time what? 6. The distance between 24, which is the equivalent force, the first equivalent force, the distance between this force and point A, how much? 6. Please make sure your distance and your force are perpendicular. The following force, the second equivalent force, 12. What is the distance between this force and point A? What is the total distance between this force and point A? 4 plus 6 plus 6 equal 16. The following force will be YB in opposite direction. So we have negative YB time. What is the total distance between YB and point A? The total distance will be 24. Nothing else equals 0. Guys, please make sure that your force and your distance are perpendicular. Anyway, this term will be cancelled, this term will be cancelled. The only unknown here will be YB. Your value of YB will be 24 times 6, 12 times 16, divide 24. This one will be 14. Once you calculated YB, I can put here YB equal 14. Then I can figure out the value of YA will be 22. So your final answer, XA equal 0, YA equal 22, YB equal 14. Do you have any question? Guys, do you have any question? Thank you, Jennifer. It's a good question. We have point A to answer your question. Point A is here. We have a force 24. We have another force, 12. We have another reaction, YB. That's right. And I am taking a moment at A equals 0. I assume this direction is positive. Okay, tell me, if you are taking a moment at A, this force times this distance will rotate clockwise. This force times distance will rotate around point A clockwise. This force times this distance will rotate around A in this direction, which is counterclockwise. So I assumed anything clockwise will be positive, so anything counterclockwise will be negative. The direction of this force and this force is different than the direction of this force. So one of them will be positive and the other will be negative. So is it clear right now? So YB is negative because YB is going up. Time this distance will rotate like this around point A, which is opposite to your assumption. So I assumed it negative. Jennifer, is it clear? Okay. One more example. But before going to the next example, I would like to remind you for something we learned last meeting. Guys, do you remember if we have a member and we have another member connected together by this shape? Do you remember what was the meaning of this shape? It was called pin connection. Do you remember that? Structure stability. Or hinge connection. Do you remember what was the meaning? I can do separation. This part alone and this part alone. This connection is hinge or pin. If you have hinge or pin, we have two reactions, one vertical and one horizontal. Do you remember what are the reactions on the other side? Do you remember that? This horizontal one will be the same here, but in opposite direction. This vertical one will be the same here, but in opposite direction. So if this one is 5, this one will be 5 also, but in opposite direction. If this one is 10, this one will be 10 also, but in opposite direction. Do you remember that? If you have pin or hinge connection, I can do separation and I can put two reactions on one side. They will be the same on the other side, but in opposite direction. I covered this last meeting, I believe. So let's do this problem. We need to figure out the reactions of this problem. Support A is roller. Support B is fixed. And we have pin connection at C. We have too many things to do in this problem. The first step we need to do separation at C. Why? Because we have pin connection at C. We learned this last meeting. So first step, I will do separation at C. This part will be alone, C, B. The other part will be here, which is C, A. Remind me, what are the reactions at A? A is roller. So we have only one reaction, YA. What about C? C was pin connection. So if you assume we have two reactions, YC and XC, like this, I believe this reaction will be the same here, but in opposite direction, like this. If this one XC, this one will be XC, but in opposite direction. If this one YC, this one will be YC, but in opposite direction. What about B? B is fixed. So we have three reactions, one vertical, one horizontal, and one moment. YB, XB, MB. Please be organized in your solution. We have pin connection, we have separation. We have roller support, we have one reaction. We have fixed support, we have three reactions. We have pin connection, we have two reactions. On one side, they will be the same values on the other side, but in opposite direction. We have we have distributed load. On this part, we have right angle triangle. So I will have equivalent here. How much? How much? 1/2 time this length 6 time this height 2. So your value will be 6. We have another distributed load, which is rectangle. On the other part, CB, I forget something here. What is the horizontal distance here? And what is the horizontal distance here? Do you remember? One of them will be 1/3, the other one will be 2/3. So I believe 1/3, 6 will be 2 meters in this side, 2/3, 6 will be 4 meters from the other side. The next one will be rectangle. So we have equivalent here. How much? How much? The area of this rectangle, 2 times 4 will be 8 kilonewton. What is the horizontal distance? What is the horizontal distance? 4 divided 2 will be 2 meters. 2 meters. So guys, do you have any comment so far? Any question? Any concern? I'm waiting for any comment.
No question. I don't have any questions.
You have one?
I do not.
Okay. Okay. One more advice. One more advice. By the end of this meeting or by the end of the day, please, one more time, you need to solve this problem with your hand without watching my recorded video. If you are doing these steps, I believe you will do great in this course, because sometimes this course, if you are watching me, looks good, but just you are catch your pencil or you are trying to use your own to solve, it will be more complicated. So please try to solve this problem one more time on your own, okay, before starting the homework. Okay, guys, we have two problems. We have two problems. The first problem, this one, how many reactions or unknowns do you have? We have YA, we have YC, we have XC. So we have 3 unknowns. The other one, how many reactions do you have? We have XC, we have YC, we have YB, we have XB, we have MB. We have 5 unknowns. Which problem or which part I'm gonna start to solve? I'm gonna start with the part with the least number of unknowns. So I will start with this part number 1. I will apply summation f of x equals 0. We have xc only equals 0. xc will be negative, equals 0, so xc equals 0. Summation f of y equals 0. We have ya minus 6 plus yc equals 0. So ya plus yc, I will push negative 6 to the other side, will be positive 6. We have equation here. I will take summation moment at a equals 0. I'm still working on this part number 1. If you take, we have 3 equilibrium equations, summation f of x, summation f of y, summation moment. I will take moment at a. So ya times 0. We don't have distance. We don't have distance between ya and point A. The next one, I'm assuming clockwise is positive. The next force, 6 times the horizontal distance, 4. The following force, yc, negative, times the horizontal distance, 6. And the next force, xc, this one, and the distance. What is the distance for xc? What is the distance for xc? Here is xc. What is the distance between xc and point A? Any answer? Thank you, Jennifer. Any more answer? Why 1, Clayton? How did you get 1? What is the meaning of 1? I cannot see any distance equal 1 for this problem. So how did you get it? Half of 2. Which 2? We have a part here, point A, and we have xc, and we have yc. I am taking a moment at A equals 0. So I'm trying to multiply xc by distance. I told you any force and any distance must be perpendicular. Your force xc is horizontal. Your distance must be vertical direction. Do you have any vertical distance? Do you have any vertical distance between xc and point A? No, we don't have any vertical distance. For this problem as a whole problem, we don't have any vertical distance. All your distance are horizontal, 6 and 4. I'm talking about xc and point A. What is the vertical distance? Why you are looking for vertical distance? Because my force is horizontal. So your force and your distance must be vertical. We don't have distance. Your distance is 0. Equals 0. So this term will be cancelled. This term will be cancelled. The only unknown is yc. Yc will be 4 kilonewton. If you go back and put yc equal 4, I can say ya equal 2 kilonewton. So finally, ya equal 2, yc equal 4, xc equal 0. Guys, this YC equals 0, so XC, I'm sorry, this XC equals 0, so XC here will be 0 also. For the other part. YC equal 4, it will be YC here equal 4 also, but in opposite direction. Right now, I can solve the second part of this problem, part number 2. I will apply also summation f of x equals 0. So we have xc minus xb equals 0. xc was 0. That means xb will be 0. I can apply also summation f of y equals 0. We have negative yc, we have negative 8, we have positive yb. This one is negative because it's down. This one is negative because it's down. This one positive because it's up. Equals 0. I believe yc is known, 4. That means the only unknown is yb will be 12. So yb equal 12, xb equal 0. The only unknown is still mb. I can do it here one more time. Here is yc equal 4. Here is xc equal 0. Here is the equivalent force equal 8. Here is YB equal 12. XB equal 0. And MB. We're still looking for MB. I applied summation f of x equals 0. I am done. Summation f of y equals 0. I am done. We still have the third equation, summation moment at any point equals 0. I will take moment at P. And I will assume the clockwise direction is positive. If I am taking a moment at B, guys, I will ask a question right now. Please pay attention. If you answer this question, I will give you 3 points extra for the coming exam. I am taking a moment at B, and I will ask a question. So please pay attention. If you answer this question, the first answer, I will give the student 3 extra points. If you take moment at B equals 0, okay, distance for YB is 0. Distance of XB is 0. If you are taking a moment at B, so the distance between YB and the point B is 0. The distance between XB and YB is 0. We don't have distance because the two forces are at the same point, B. What is the distance for MB? I am taking a moment at B. So what is the distance for MB? Distance for XB is 0. Distance for YB is 0. What is the distance for MB?
It should be 0.
0. Thank you, Benjamin. Zach, thank you. Marcos, no distance. Any other question? Any other answer? What is the distance? Guys, be careful. MB at point B, XB at point B, YB at point B. So if you are taking a moment at B, so YB will be times 0, XB times 0. What is the distance for MB? It should be 0 also or something different. Today is January 21. So Marcos will have extra 3 points. Marcos, yes. You are right. You are right. We don't need distance. We don't need distance for MB. I'm sorry, what you mean by we don't need distance? Guys, moment equal force time distance. If you have a force, you need distance to get a moment. But MB is a moment. Is a moment as a reaction. Do you think we still need distance? We don't need distance. It's wrong to put a distance here. Wrong. So I will add MB. That's it. Because MB is a moment and I'm looking for moment at B. We don't need distance for this reaction because it's a moment. If this reaction is a force, still need distance. If this reaction is a force, still need distance. But if this reaction is a moment, does not need distance. What else? -8 times this horizontal distance, how much? 2. You have to consider everything in the problem. If you are taking moment at B, we need to consider these reactions, this force, this one, and this one. What else? Negative YC, which is 4, times the total distance will be 4. This total distance will be 4. What else? XC times 0. We don't have distance between this XC and your point B. We don't have distance. We don't have distance. Equals 0. This term will be cancelled. This term will be cancelled. This term will be cancelled. The only unknown in this problem is MB, so I can figure out the value of MB. It will be 32. So finally, MB equal 32, YB equal 12, XB equal 0, YC, YA, all reactions are calculated. One more example. One more example. We have frame. We need to determine the reaction at support A, which is roller, and the support C, which is hinge or pin. So we have A is a roller. So we have one reaction, YA. C is pin or hinge support, so we have two reactions, YC and XC. We have three equilibrium equation, summation f of x equals 0, What do you have in x direction? Positive xc, negative 2 equals 0. So xc equal to summation f of y equals 0. What do you have in y direction? We have ya positive. We have negative 6. We have positive yc. Anything else in y direction? No. Simplify this equation, so ya plus yc equals 6. The third equilibrium equation, summation moment at any point equals 0. I'm gonna take moment at C. I highly recommend to take moment at support with the highest number of reactions. If you are taking a moment at a point, I highly recommend to take moment at support with the highest number of reactions. So I'm gonna take moment at support C because we have 2 reactions at C. If you are taking a moment at C, XC times 0. We don't have distance for XC. YC times 0. We don't have distance for YC. What else? If you are taking moment at C, please don't forget any. 2 times 2. I'm assuming clockwise direction is positive. So 2 times 2 will be negative. Guys, I'm taking moment at C and this force 2. What is the distance between this force and this point? Your distance will be vertical because your force is horizontal. So we have perpendicular. And the negative y because this force will rotate around this point like this, which is counterclockwise. It will be negative because I assume the clockwise is positive. What else? This 6. Time what? What is the distance between this force and the point C? This force is vertical, so your distance will be horizontal. Your distance will be 2. Negative also, counterclockwise. The rotation direction is counterclockwise. What else? Please don't forget any. We have positive YA. This force is vertical, so your distance will be horizontal 4. The horizontal distance between this force and point C. 4. And it rotating clockwise direction, so it's positive. Equals 0. This term will be cancelled. This term will be cancelled. The only unknown is YA, so I can figure out the value of YA. It will be 4. If you go back here and put YA equal 4, I can figure out the value of YC will be 2. So finally, YC equal 2, XC equal 2, YA equal 4. I am done with the reactions. So guys, please don't forget the force, time, distance. To get a moment, your force and your distance must be perpendicular. If your force is vertical, your distance must be horizontal. If your force is horizontal, your distance must be vertical. If you don't have distance, your distance will be 0. One more example. Any question? One more example. Example number 6. We need to determine the reactions. A is hinge. D is hinge. B is pin connection. Do you remember that? if you have pin connection, we need to do separation at this connection. So this frame will be separated like this. Here is the first part, A, B. The second part, B, C, D. That makes sense? That makes sense. So we have two parts like this problem. Example number 4. What do you have? A is hinge, so we have two reactions. YA, XA. D is hinge, so we have two reactions. YD, XD. B is pin connection, okay? If you assume two reactions here, XB and YB, they will be the same here, but in opposite direction, XB and YB. What else do you have? We have uniform distributed load. We have two concentrated load, 8 and 8. So I can solve this problem. I can make two problems, part number 1 and the part number 2. I will apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0 for the first part. The second part is the same, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. So I can solve for these reactions. So I can solve for all of these reactions. One more thing. This equivalent force, we will have one like this in the same direction for these arrows. How much? 3 times this length. What is the length of this member? We have 3, we have 4, so this length will be 5. 3 times 5 will be 15 kilonewton.